In the year 1995, in the month of December, the Hubble Space Telescope turned its mirror toward a small patch of sky near the handle of the Big Dipper. This region held no bright stars, no known nebulae, no galaxies that astronomers had cataloged or named. It was, by every measure that mattered at the time, an empty place, a dark corner of the heavens where nothing seemed to reside. The telescope would remain fixed on this emptiness for 10 consecutive days. To understand why anyone would do such a thing, you must first understand how precious telescope time truly is. Hubble orbits the Earth every 97 minutes, and researchers from around the world compete fiercely for even a few hours of its attention. There are always more questions than there is time to answer them. Always more objects to study than there are orbits in which to study them. And yet the director of the Space Telescope Science Institute, a man named Robert Williams, chose to spend his discretionary time, his personal allotment of the telescope's gaze, staring at nothing. His colleagues thought it was a waste. Some of them said so openly. The patch of sky he selected was approximately the size of a grain of sand held at arm's length. If you were to go outside on a clear night and extend your hand toward the stars, and if you were to hold a single grain of sand between your thumb and forefinger, that grain would cover roughly the same portion of the sky that Hubble examined. This is a useful thing to remember. The universe tends to reveal itself in portions we can almost comprehend if we are patient enough to look. The region was chosen precisely because it was boring. It sat far from the plane of the Milky Way, where dust and stars crowd together in luminous confusion. It avoided the known clusters and the mapped structures that astronomers had already begun to chart. It was a window into the deep, a keyhole through which one might peer beyond the local neighborhood of the cosmos and into the emptiness between. Or what everyone assumed was emptiness. The exposures began on December 18th and continued through December 28th. Hubble circled the Earth again and again, and during each orbit it gathered a little more light from that dark and silent place. The individual exposures lasted between 15 and 40 minutes, and there were 342 of them in total. Slowly, pixel by pixel, an image began to form. You can think of it as a kind of listening. The telescope was not merely looking at the sky. It was waiting for photons that had been traveling for billions of years. Some of those photons had left their sources when the universe was young, when galaxies were still assembling themselves from primordial clouds of hydrogen and helium. They had crossed distances so vast that the space they traveled through had itself expanded during their journey. And now, after all that time and all that distance, they were arriving at a mirror 60 feet above the atmosphere, one by one, in almost perfect silence. The mirror collected them, the instruments recorded them, and the image deepened. If you were to watch this process unfold, you would see very little at first. The early exposures would show only noise, the random scatter of detector artifacts and cosmic ray strikes, bright pixels that meant nothing and dark pixels that hid everything. But as the hours accumulated, as exposure layered upon exposure, patterns would begin to emerge from the static. Faint smudges of light, too dim to see in any single frame, would start to resolve into shapes, spirals, ellipses, irregular blobs with no clear structure at all. These were not stars. Stars appear as points of light, sharp and well-defined. What was emerging from the darkness was something else entirely. These were galaxies. Thousands of them. In a patch of sky that had seemed to contain nothing at all, Hubble found approximately 3,000 galaxies. Some of them were relatively nearby, only a few billion light-years distant, their light having begun its journey when the Earth was already old. Others were inconceivably far, their photons having left home more than 12 billion years ago, when the universe itself was less than a billion years old. The image contained galaxies at every distance, galaxies at every stage of development, galaxies in shapes that astronomers had never seen before. And this was only one tiny window, one grain of sand. The mathematics of what this implied was not difficult to calculate, though the result was difficult to accept. If this single small region contained 3,000 galaxies, and if the entire sky contained millions upon millions of such regions, then the total number of galaxies in the observable universe must be staggeringly large. Early estimates suggested hundreds of billions. Later studies would revise this number, first upward and then with more nuance, but the essential revelation remained. The universe was not merely large, it was populated beyond any reasonable expectation. Everywhere you looked, if you looked long enough, you would find light. The image that resulted from those 10 days of observation came to be known as the Hubble Deep Field. It is not the most beautiful image ever taken of the cosmos, though it possesses a strange and quiet beauty of its own. It does not show the dramatic pillars of gas where stars are born, or the delicate shells of dying suns, or the intricate dance of colliding galaxies frozen in mid-embrace. What it shows is something simpler and perhaps more profound. It shows depth. It shows time. It shows the universe as it actually is, which is to say, full. Look at the image now if you can hold it in your mind. A field of black scattered with points of light and smears of light and spirals of light. The black itself is not truly black, of course. It is merely the places where the light has not yet arrived, or where the light is too faint for even Hubble to detect. If you were to look longer with a larger mirror, you would find more galaxies there as well, and more beyond those. The darkness is not emptiness, it is simply patience. Some of the galaxies in the image appear as neat spirals, their arms curling gracefully outward from a bright central core. These are the familiar shapes, the ones that grace posters and documentaries, the ones we think of when we imagine a galaxy. But many others have no such order. They are lumpy and irregular, their light distributed in blotches and streaks with no discernible pattern. These are often the most distant objects in the image, galaxies so young that they had not yet settled into the graceful forms we associate with maturity. They were still becoming. They were still deciding what shape they would take. And somewhere among them, though we cannot know exactly where, there may be galaxies that have since given birth to worlds not unlike our own. Worlds with water and rock and the slow chemistry of life. The light we see from those galaxies shows us only what they were, not what they have become. The universe keeps its secrets separated by time as much as by distance. To look at the Hubble Deep Field is to look at the past. This is true of all astronomical observation, of course. Light travels quickly, but not infinitely quickly, and the universe is very large. When you look at the moon, you see it as it was a little more than a second ago. When you look at the sun, you see it as it was 8 minutes ago. When you look at the nearest star beyond the sun, you see it as it was 4 years ago. And when you look at the farthest galaxies in the Hubble Deep Field, you see them as they were more than 12 billion years ago. The light arriving at your eyes has been traveling since before the Earth existed. This is not a metaphor or an approximation. It is simply what is happening. The photons striking Hubble's detectors during those December nights in 1995 had departed their sources in the early epochs of the cosmos, when the universe was dense and hot, and galaxies were forming for the first time. They had traveled through the expanding dark, through regions of space where no stars yet shone, through the long emptiness between superclusters, until finally they arrived at our small corner of the cosmos and ended their journey on a detector designed by human hands. Each photon told a story, though most of those stories will never be fully understood. What remains is the image itself, a field of faint light against a background of almost perfect black, a census of distant islands, each one home to hundreds of billions of stars. A reminder that when we point our instruments at the sky and ask what is out there, the answer is almost always more than we expected. More light, more structure, more time made visible. The Hubble Deep Field changed the way we understand the cosmos, not because it revealed something shocking or dramatic, but because it revealed something quiet and true. The universe is vast beyond imagination, and it is filled with light. Everywhere you look, there is something to see. You need only be patient enough to look. And so we begin our journey here at the edge of that image, where the faintest galaxies blur into the noise and the light is barely distinguishable from the dark. We will move slowly, as light does across the cosmos. We will take our time. There is no hurry. There is only the looking and the long, quiet act of seeing. For 10 consecutive days in December of 1995, the Hubble Space Telescope held its gaze on a single patch of sky. It did not move. It did not waver. It simply waited, collecting light so faint that no human eye could ever perceive it, no matter how long one stood beneath the stars and hoped. The patch of sky it watched was small, smaller than you might imagine. If you held a grain of sand at arm's length against the night, the area it covered would be roughly the size of this field. A grain of sand. And within that grain, the telescope found galaxies beyond counting. But the image did not arrive all at once. It returned in pieces, in exposures gathered over those 10 days, each one adding a little more depth to the darkness. The telescope circled Earth every 90 minutes or so, and during each orbit it could only observe the target field for a portion of that time. The rest was spent in shadow, or pointed away, or simply waiting. Patience was built into the observation itself. "342 separate exposures were taken. Some captured blue light, some red, some the invisible wavelengths that lie just beyond what we can see. Each exposure was a layer, a transparency laid over the others, until gradually the image began to emerge from the static. Think of it as developing a photograph in a darkroom, except the darkroom is space itself, and the photograph takes more than a week to resolve. With each added exposure, faint smudges became clearer. Points of light that seemed like noise revealed themselves to be something more. The image deepened, not in the way a pit deepens, but in the way a memory deepens when you return to it again and again. There were challenges. Cosmic rays struck the detector during those long exposures, leaving bright streaks across the data like scratches on old film. These had to be identified and removed carefully so that the true signal could be preserved. The telescope itself drifted slightly, as all orbiting objects do, and these tiny motions had to be corrected so that the images could be stacked precisely, one atop another. The stars and galaxies aligned across hours and days of observation. The people who did this work were patient. They had to be. They were not seeking a quick answer or a dramatic revelation. They were building something slowly, the way one might build a house from stones gathered one at a time from a riverbed. Each stone matters. Each exposure matters. And when you step back at last, what you see is not the stones themselves, but the shape they have made together. The final image was released in January of 1996. It was, in a sense, nothing more than a picture, a rectangle of light and dark, color and shadow, no larger than a photograph you might hold in your hand. And yet what it contained was not a landscape or a portrait or a moment frozen in time. It was a window, and through that window one could see back across billions of years. Imagine you are holding that image now. Not on a screen, but as a physical thing printed on paper, the colors slightly muted by the medium. You can see the scattered points of light, some sharp and clear, others soft and diffuse. A few are obviously stars, their light spread into tiny crosses by the optics of the telescope. But most of what you see are not stars at all. They are galaxies, each one a collection of billions of stars, held together by gravity, drifting through a universe so large that the light from these objects has been traveling for longer than Earth has existed. Some of them appear as spirals, their arms curving outward like the slow unwinding of a thought. Others are elliptical, soft, and rounded, their stars distributed in a haze that has no clear edge. Still others are irregular, torn or twisted by collisions long past, their shapes defying easy description. And some are so distant, so faint, that they appear as little more than red smudges. These are the oldest objects in the image. Their light has been stretched by the expansion of the universe itself, shifted from blue to red over the course of its journey. By the time it reached the telescope, that light had been traveling for more than 12 billion years. $12 billion years. Say it slowly and let the words settle. The universe itself is only a little older than that. When the light from these galaxies began its journey, the cosmos was young. Stars were forming at rates far higher than they do today. Galaxies were colliding and merging, building the larger structures that would one day become the clusters and superclusters we observe in the nearby universe. Everything was closer together, hotter, more turbulent. And here in this image, we see that era preserved, not as a reconstruction or a simulation, but as actual light that left those galaxies when the universe was still finding its shape. The image that returned was not just data. It was a kind of gift, sent across time by objects that did not know they were sending it. Each galaxy emitted its light in all directions, indifferent to where it might land. Most of that light is still traveling now, will travel forever, will never encounter anything at all. But a small fraction, a vanishingly small fraction, happened to be pointed in exactly the right direction to reach a telescope orbiting a small planet around an ordinary star in an unremarkable corner of the Milky Way. We were waiting for it. We built the instrument, chose the target, opened the shutter, and waited. And the light came. This is worth pausing on. The collaboration between the observer and the observed spans not just space but time. The galaxies did their part billions of years ago, sending out photons that would travel in silence through the void. We did our part much later, constructing a machine capable of catching those photons and recording their presence. Neither party knew the other existed, and yet the connection is made every time we look at the image. There is something quietly sacred about this, not in a religious sense, but in the sense of something rare and worth protecting. The image exists because of patience and precision, because of the willingness to point a telescope at what appeared to be empty sky and trust that something would be there. It exists because the universe is old enough and large enough to contain objects so distant that their light has been traveling since before our solar system formed. When astronomers first examined the completed image, they counted the galaxies by hand. It took time. There were roughly 3,000 of them crowded into that tiny patch of sky. 3,000 galaxies in an area smaller than a grain of sand held at arm's length. The implications of this were immediate and profound. If this small patch contained so many galaxies, then the entire sky must contain far more than anyone had previously estimated. The numbers were revised upward, again and again, as deeper observations followed in the years to come. The universe was more crowded than we had known, more filled with light, with structure, with history. And all of it had been there, waiting, long before anyone thought to look. Consider the colors in the image. They are not arbitrary. The blue galaxies are those where new stars are forming, their light dominated by the hot, bright glow of young stellar populations. The red galaxies are older, their stars cooler and more settled, or so distant that their light has been reddened by the expansion of space itself. The colors tell a story about age and distance, about the life cycles of stars and the structure of the cosmos. Some galaxies appear to overlap in the image, though they are in fact separated by vast distances. One might be 2 billion light years away, another 10 billion, and yet from our vantage point they seem to touch, their light mingling on the detector. This is a reminder that depth is hidden in the image. What looks flat is anything but. You are seeing through the universe, layer after layer, each galaxy at its own unique distance, each one isolated in the dark. The image that returned is still being studied. Decades have passed since it was first released, and astronomers continue to find new details, new questions, new reasons to look again. It has been compared to other deep field images taken since, some even deeper, some covering different parts of the sky. Each new observation adds to our understanding. But this one, the original Hubble Deep Field, remains a touchstone. It was the first time we truly saw how far we could see. And what we saw was not emptiness, it was fullness. A sky that appeared dark and featureless was revealed to be alive with light, ancient and patient, waiting for us to notice. The image is quiet now. It sits in archives, in databases, in books and papers and presentations. It has been reproduced countless times, in countless formats. And yet it remains what it has always been, a record of light gathered over 10 December days, a portrait of the universe as it was and as it is, a still point in the long history of human curiosity. Let it rest in your mind for a moment. There is no need to move on yet. The galaxies are not going anywhere. Their light has already arrived, and it will be here as long as we care to look. The image that returned is still returning, still offering itself to anyone patient enough to receive it. Breathe slowly. Let your eyes soften. The universe is old, and it is large, and it is full of light that has been traveling longer than you can imagine. Some of that light is in front of you now, captured and preserved, waiting. Let your gaze settle now on the closer shapes, the ones that seem almost familiar. Among the thousands of galaxies scattered across this small patch of sky, some rest nearer to us than others, their light having traveled only a few 100 million years to reach the telescope's patient eye. In cosmic terms, these are our neighbors, though the word feels strange when applied to distances so vast that light itself requires hundreds of millions of years to cross them. These nearby spirals appear larger in the frame, their arms more clearly defined, their structures easier to trace. You can see the gentle curl of their forms, the way dust lanes wind through their disks like rivers viewed from a great height. They are not simply points of light, but places, each one a collection of hundreds of billions of stars held together by gravity's quiet insistence. Consider one of these spirals now, tilted slightly toward us so that you can see its face. The arms emerge from a bright central core and sweep outward in graceful curves, thinning as they reach toward the edges. Along these arms, clusters of young blue stars shine with a light that is almost cold in its intensity. These are the newest stars in the galaxy, born from clouds of gas and dust that have collapsed under their own weight. They burn hot and fast, and many of them will exhaust their fuel in only a few million years. Between the arms, the light grows softer, more yellow and orange. Here dwell the older stars, the ones that have been circling the galactic center for billions of years. They are patient travelers, these ancient suns, and they carry with them the memory of an earlier universe. Some of them formed when their galaxy was young, when the first clouds of hydrogen were just beginning to gather and ignite. The light from this spiral left its source perhaps 300 million years ago. On Earth, at that moment, the Carboniferous period was drawing toward its close. Vast forests of ferns and primitive trees covered the land, and the first reptiles were beginning to appear. The continents were arranged in unfamiliar positions, gathered together in ways that would seem strange to modern eyes. Insects with wingspans the length of your arm drifted through humid air, and the oceans teemed with life that has since vanished entirely. All of this was happening on Earth while the light now entering your eyes was just beginning its journey. It departed from a star in that distant spiral, streamed outward into the void, and traveled through the expanding darkness for 300 million years without touching anything at all. And now, finally, it arrives. Imagine drifting closer to another spiral, this one seen more edge-on, so that it appears as a thin line of light bisected by a dark band of dust. From this angle, the galaxy resembles a luminous disk viewed from its side, and you can see how remarkably flat it is. The dust lane running through its center is not emptiness but substance, clouds of particles so thick that they block the light of the stars behind them. This dust is rich with heavy elements, carbon and oxygen and silicon, the materials from which planets are made. Spiral galaxies like this one, and like our own Milky Way, are still actively forming stars. The dust and gas in their disks provide the raw material, and gravity does the rest. Over millions of years, regions of higher density attract more matter, growing denser still, until the pressure at their cores becomes great enough to ignite nuclear fusion. A star is born quietly, without fanfare, adding its light to the billions that came before. The color of a spiral galaxy tells you something about its history. Bluer regions indicate recent star formation, places where massive young stars are pouring out ultraviolet radiation that excites the gas around them. Redder and yellower regions suggest older stellar populations, stars that have settled into the long, slow burn of middle age. Most spirals display both colors, a mixture of youth and age coexisting in the same vast structure. Some of these nearby spirals show signs of interaction with other galaxies. Their arms may appear slightly distorted, pulled out of their perfect curves by the gravitational influence of a passing neighbor. These encounters unfold over hundreds of millions of years, far too slowly for any human lifetime to perceive. Two galaxies might spend longer approaching each other than complex life has existed on Earth. And yet, in the Hubble image, you can see the evidence of these slow dances frozen in a single moment. When galaxies interact, they rarely collide in the way that solid objects do. The stars within them are so widely spaced that most pass by one another without incident. But the gas and dust between the stars can compress and heat, triggering bursts of new star formation. Some interacting galaxies glow with unusual brightness because of this, their disks lit by the light of millions of newborn suns. Let your attention rest now on a spiral that appears almost face-on, its arms spread wide like the petals of a flower seen from above. Notice how the arms are not solid structures, but patterns, density waves moving through the disk of the galaxy like ripples moving through water. Stars drift into these waves and linger there, slowed by the crowded conditions, before eventually moving on. The arms persist even as the stars within them change, a form maintained by motion rather than substance. At the center of this spiral, a soft golden glow marks the bulge, a dense collection of older stars clustered around the galactic core. Deep within this bulge, hidden from view, there almost certainly resides a supermassive black hole. Most large galaxies harbor such objects at their centers, and they can contain the mass of millions or even billions of suns. In some galaxies, these black holes are actively feeding, pulling in gas and dust that heats up and radiates brilliantly before crossing the event horizon. But in many spirals, including this one, the central black hole is quiet, dormant, waiting. The light from this galaxy has traveled perhaps 200 million years. When it began its journey, the Triassic period was underway on Earth. The first dinosaurs were small and unassuming, not yet the dominant creatures they would become. The supercontinent Pangaea was still intact, a single vast landmass surrounded by a global ocean. The ancestors of mammals were present, but they were modest beings, living in the shadows of larger reptiles. "200 million years is a span of time almost impossible to grasp. And yet, in the context of the universe, it is recent. The light from these nearby spirals is young light, carrying news from a cosmos not so different from the one we inhabit today. The galaxies that emitted this light have continued their slow rotations in the time since, turning through a portion of a single orbit, their stars drifting along their appointed paths. Notice how the spiral arms of these galaxies are not perfectly symmetrical. One arm may be brighter than another, or more tightly wound. Small companion galaxies or past interactions may have introduced asymmetries that persist for billions of years. Each spiral carries the record of its history in its shape, though reading that record requires patience and careful observation. The distances to these galaxies, a few 100 million light years, place them well beyond the local group where our own Milky Way resides. They are part of the larger cosmic web, strung along filaments of dark matter that span the observable universe. Between the filaments lie vast voids, regions of space where galaxies are rare, and the darkness extends for tens of millions of light years in every direction. But here, in the Hubble Deep Field, we are looking through these structures, seeing galaxies at many different distances superimposed on one another. The nearby spirals we contemplate now are merely the foreground of a much deeper scene. Behind them and between them lie galaxies whose light has traveled far longer, carrying news from epochs when the universe itself was young. For now, though, let us remain with these spirals, these familiar shapes. There is comfort in their recognizable forms, in the knowledge that the same physical processes that shaped our own galaxy have shaped these as well. The same gravity, the same nuclear fusion, the same patient accumulation of matter over billions of years. We are looking at cousins of the Milky Way, siblings born from the same cosmic conditions, evolving along parallel paths. The light from these galaxies is steady and soft. It does not flicker or pulse. It arrives with the constancy of something that has been traveling for so long that haste has become meaningless. Each photon was emitted by a star that may or may not still exist, that may have since exploded or faded or been swallowed by a companion. We see the past, always the past, and we accept this as the condition of looking outward into space. These nearby spirals will remain in the image, unchanged, for as long as humans care to study them. They were captured in a moment of stillness, their slow rotation frozen, their countless stars fixed in place. And yet they are not truly still. They are turning, always turning, completing a single rotation every few 100 million years, their arms sweeping through space like the hands of a clock too slow to watch. Rest here for a moment. Let the spirals hold their shapes in your mind. There is no hurry to move on, no urgency to look deeper. The light will wait. It has been waiting for a very long time. Let us move deeper now. As we drift further into the field, the galaxies grow smaller, fainter, and their colors begin to change. The soft whites and yellows of the nearby spirals give way to something quieter, something older in its journey to reach us. Here, at the edges of visibility, we find galaxies glowing in shades of amber and rust, their light stretched thin by the expansion of space itself. These are the distant red galaxies. They appear as small smudges, some barely distinguishable from the darkness around them. A few are no larger than a grain of sand held at arm's length, yet each one contains billions of stars. Their redness is not intrinsic to them. When this light first departed, it was bluer, younger, more energetic. But the universe has been stretching all this time, and the light has stretched with it, its wavelengths elongating into the red and infrared as it traveled across billions of years to reach this small patch of sky. Imagine you are drifting toward one of them now. It hangs in the field like a drop of rust suspended in dark water. There is no defined spiral structure here, no elegant arms sweeping around a bright nucleus. Instead, the galaxy appears irregular, patchy, as though it has not yet decided what shape it wishes to become. And perhaps it has not. What we are seeing is a galaxy in the act of formation, a structure still assembling itself from the raw materials of the early universe. The light from this galaxy left its source more than 10 billion years ago. The universe was young then, perhaps 3 or 4 billion years old, a fraction of its current age. Stars were forming at rates we do not see in our present epoch, great bursts of stellar birth occurring in dense clouds of hydrogen and helium that had only recently begun to collapse under their own gravity. The galaxies of that era were not the stately, organized systems we see nearby. They were turbulent, active, still finding their form. When you look at one of these distant red smudges, you are not seeing a finished thing. You are seeing a process interrupted by distance, frozen in time by the finite speed of light. The galaxy has continued to evolve in the billions of years since this light departed. It may now be a grand spiral or a massive elliptical, or it may have merged with its neighbors to become something else entirely. We cannot know. We see only what it was, not what it has become. There is a gentleness to this realization. The universe offers us its past so freely, spreading it across the sky for anyone patient enough to look. These red galaxies ask nothing of us. They simply glow, faintly, at the edge of what our instruments can perceive. Let your attention settle on another shape nearby. This one is slightly larger, though still small by the standards of the spirals we visited earlier. It has a faint elongation, a hint of structure that suggests rotation, but the details are lost to distance and time. The color is a deep ochre, almost brown in places, where dust and stretched light combine to mute any brightness that might have once been there. Surrounding it, if you look carefully, are smaller points of light, some of which may be companion galaxies caught in the same gravitational well. Others merely foreground stars from our own Milky Way, intruding quietly into the frame. The distinction between stars and galaxies is not always obvious in the deep field. Stars appear as points with tiny diffraction spikes, artifacts of the telescope's optics. Galaxies, even the smallest ones, have a softness to their edges, a fuzziness that reveals their extended nature. But at these distances, some galaxies are so compact that they too appear nearly point-like. Only their colors and their faintness give them away. A star from our own galaxy, no matter how dim, would not glow with this particular shade of red. That color belongs to the stretched light of the distant universe alone. Consider what was happening within one of these galaxies when its light began its journey. The first generation of stars, those massive and short-lived giants forged from pure hydrogen and helium, may have already come and gone. Their explosive deaths would have seeded the surrounding gas with heavier elements, carbon and oxygen and iron, the materials from which future generations of stars and planets would form. The second generation of stars was perhaps already burning, smaller and longer-lived, incorporating those new elements into their cores. Planets may have been forming as well, though the universe was still relatively poor in the heavy elements needed to build rocky worlds like our own. Any planets orbiting those ancient stars would have been different from Earth, perhaps gas giants with cores of ice and compressed hydrogen, or small, barren worlds of silicate and metal. Life, if it existed at all in that epoch, would have faced a universe still settling into its long-term patterns, still punctuated by the violent deaths of massive stars and the mergers of young galaxies colliding in the denser environment of the early cosmos. We do not know if life existed then. We do not know if it exists now in those places, 10 billion years further along in their histories. The light cannot tell us. It carries only information about what was, not about what is or what might be. And so we are left with questions that the deep field raises but cannot answer. Questions that settle into the silence like dust settling in still air. Drift a little further. Another red galaxy comes into view, this one smaller still, a mere fleck of warmth against the cold black. It is so faint that it required many hours of exposure to reveal itself. The Hubble Space Telescope staring patiently at this single patch of sky while the Earth turned beneath it. Photon by photon, the image accumulated, each particle of light having traveled for eons only to end its journey on a detector no larger than a postage stamp. There is something almost reverent in that. The patience of the observation matching the patience of the light itself. This galaxy, small as it appears, may contain 100 billion stars, or it may contain only a few billion, a dwarf galaxy in the process of forming, destined to be absorbed by a larger neighbor in the eons to come. Its small size in the image tells us only about its distance and its apparent brightness. The true scale of things is hidden behind the mathematics of cosmology, accessible only through careful measurement and inference. What we see is a suggestion, a hint, a whisper of something vast disguised as something small. The redness of these galaxies is a kind of signature, a mark of their remoteness. Astronomers call it redshift, this stretching of light toward longer wavelengths. The greater the redshift, the faster the galaxy appears to be receding from us, and the farther away it is. These distant red galaxies have redshifts that place them at the edge of the observable universe, or near to it. They are among the most remote objects ever photographed. Their light-carrying information from an epoch when the universe was a fraction of its current size. It is worth pausing here to consider what that means. When this light left its source, the universe was smaller, denser, hotter. The space between galaxies has expanded in the intervening billions of years, carrying the galaxies with it like raisins in rising bread. The redness we see is a record of that expansion, a visible trace of the universe's growth encoded in the color of ancient light. Every photon that reaches us from these distant sources carries within it a measure of cosmic history, a timestamp written in wavelength. And yet the galaxies themselves did not feel this expansion. Within each galaxy, gravity held the stars together, resisting the outward pull of expanding space. The stars orbited their common center, oblivious to the vast stretching happening in the voids between galaxies. It is only when we look across those voids, across billions of light years, that the expansion becomes visible. The redness is a phenomenon of the journey, not of the source. Let your gaze soften now. Do not try to focus on any single galaxy. Instead, allow the field to blur slightly, to become a wash of faint color against darkness. Notice how the red galaxies cluster together in some areas and thin out in others. This is not random. Even at these great distances, the large-scale structure of the universe is visible. The web of filaments and voids that formed as matter clumped together under gravity in the early cosmos. The deep field, small as it is, contains a cross-section of this structure, a core sample drilled through billions of years of cosmic time. The galaxies we see here are not evenly distributed. They congregate along invisible threads of dark matter, that mysterious substance that outweighs ordinary matter by a factor of 5 or more. We cannot see the dark matter directly, but we see its effects in the arrangement of galaxies, in the way they cluster and stream along paths determined by gravity's patient hand. The red galaxies trace these paths, marking the scaffolding of the universe at an epoch when that scaffolding was still under construction. Rest here for a moment longer. There is no urgency in this place. The light has already traveled for 10 billion years. A few more seconds of contemplation changes nothing and costs nothing. The distant red galaxies will remain as they are, faint smudges of ancient light, for as long as the Hubble Deep Field image exists. They are fixed in time, suspended between the moment of their emission and the moment of their detection, their ongoing evolution hidden from us by the speed of light and the vastness of space. These galaxies were still forming when their light departed. They may be fully formed now, mature and stable, their stars quietly burning through their fuel over timescales we can barely comprehend. Or they may have changed beyond recognition, their identities merged with others, their individual histories lost in the larger flow of cosmic evolution. We see them only as they were, young and turbulent and red with the stretching of space. That is enough. That is what the deep field offers, and it is more than enough to hold in the quiet of this moment. In certain corners of this image, the galaxies are not alone. They have found each other across the emptiness, and now they are slowly, silently coming apart. Look here, where two spirals have begun to touch. Their outer arms reach toward one another like hands extended in the dark. The stars within them have not collided, not truly. The distances between individual stars remain so vast that most will pass by one another without contact, like drops of rain falling through a forest. But the galaxies themselves, the great structures of dust and gas and gravitational intention, these are being unmade. This process has no sound. There is no crash, no thunder rolling across the void. It unfolds across hundreds of millions of years, so slowly that a human lifetime would capture only the faintest shift. If you watched from one of the worlds caught in this embrace, you might not notice anything at all, not for countless generations. And yet the transformation is real. It is happening now, in light that has traveled so far to reach us. When two galaxies pass near one another, gravity becomes a sculptor. The stars feel the pull of a new center, a new mass drawing them out of their familiar paths. Tidal forces stretch the spirals into ribbons, into bridges of light that span the space between. These structures have names in our catalogs, tidal tales and stellar streams, but the names do not capture their strangeness, the way they curve and flow like something poured from a vessel in slow motion. The galaxies here are caught in mid-act. They have begun something they cannot undo. Consider the light you are seeing now. It left these galaxies when they were already in motion toward one another, already feeling the first gentle tug of mutual attraction. What you see is a moment frozen in amber, one frame extracted from a transformation that began before our sun existed and will continue long after Earth has grown cold. Where are these galaxies now in this very instant? We cannot know for certain. They may have completed their merger, settled into a single elliptical form, their spiral arms dissolved into a smooth cloud of ancient stars. Or they may still be dancing, circling one another in a widening gyre, preparing for another close passage in a few 100 million years. The light does not tell us where they are. It tells us only where they were. Here is another pair, smaller and more distant. Their shapes are harder to discern. One appears to be a compact elliptical, dense and round, while the other shows the faint trace of spiral structure. They are so close together that in this image they nearly touch, their halos of starlight overlapping into a single glow. At the distance these galaxies inhabit, we see them as they were perhaps 10 billion years ago. The universe was younger then, denser. Galaxies were closer together on average, and encounters like this were more common. In the early epochs, collisions were not rare accidents but frequent events, shaping the population of galaxies we see around us today. Many of the great elliptical galaxies in the nearby universe, the massive red spheres that anchor the centers of galaxy clusters, are thought to have formed this way. They are the products of mergers, the calm aftermath of collisions that happened long before our sun began to burn. What you are watching in this faint smear of light may be the birth of one of those ancient giants. There is a kind of violence here, though it does not feel violent. Stars are being thrown from their homes, scattered into intergalactic space where they will drift alone for eternity. Gas is being compressed and heated, triggering bursts of star formation in regions that were quiet before. Some of this gas will fall toward the centers of the merging galaxies, feeding supermassive black holes that lurk there, causing them to flare with light that can outshine everything around them. But from our vantage, so far away, so long after, all of this appears gentle. The colors are soft. The shapes curve and flow. There is a beauty in the destruction that is hard to name. Let your eyes move now to a smaller form, alone in the dark but bearing the marks of a past encounter. Its shape is irregular, neither spiral nor elliptical, a smudge of blue-white light with no clear center. This may be a galaxy that has already survived a collision, emerging changed, its structure disrupted beyond recognition. Or it may be a fragment, a piece thrown off from a larger merger, now drifting as an independent system. These fragments can persist for billions of years, small islands of stars that were once part of something greater. They carry within them the history of an event they can no longer remember. We see many irregular galaxies in the Hubble Deep Field. At these distances and these look-back times, they are more common than they are in the nearby universe. This tells us something about cosmic history, that the universe was once a rougher place, full of encounters and disruptions, and that it has slowly grown calmer, the galaxies spacing themselves out, the collisions becoming rare. The universe is settling. Here, two galaxies are connected by a bridge of stars. The bridge is faint, barely visible, a whisper of light spanning the gap between them. It is made of stars that have been pulled from their parent galaxies, drawn out by the tidal forces of the encounter. Some of these stars will fall back eventually, returning to one galaxy or the other. Others will remain in the bridge, part of a structure that belongs to neither galaxy, suspended between. There is something lonely about these stars, if loneliness can be applied to objects without minds. They were once part of a system, orbiting a center, moving with companions. Now they drift in the space between, their futures uncertain. But perhaps loneliness is the wrong word. Perhaps they are simply free. When two spiral galaxies merge completely, the result is often an elliptical. The ordered rotation of the spirals, stars moving in neat circles around a central hub, is replaced by something more chaotic. Stars orbit in all directions, their paths crossing and recrossing like threads in a tangled knot. The structure becomes smooth, featureless, the memory of the spirals erased. This process takes time. First, there is the approach, gravity bending the paths of both galaxies toward one another. Then the first passage, a close flyby that distorts both shapes, throwing out tails and bridges. The galaxies swing past one another, moving apart again, slowed by the gravitational pull they still exert. Then they fall back, passing close again, distorting further. Each passage draws them tighter, steals more of their momentum, until finally they cannot escape. They settle into one another, their stars mixing, their black holes sinking toward a common center. The black holes themselves may eventually merge, releasing a pulse of gravitational waves that ripples outward through space-time. We have learned to detect such pulses from mergers much closer to us. It is possible that somewhere in this image, in one of these faint colliding systems, such a merger has already occurred, billions of years ago, sending waves that passed through our solar system before Earth was formed. We would have no way to know. The waves are gone, and only the light remains. There is a pair here that appears almost face-on, two spirals overlapping like rings on a still pond. The dust lanes of one galaxy cross the starlight of the other, creating a pattern of shadow and glow. It is difficult to tell at this distance whether these galaxies are truly interacting or simply appear close together by chance, one behind the other along our line of sight. Such alignments happen. In an image containing thousands of galaxies, some will overlap without touching, but the shapes of these two suggest otherwise. There is a slight distortion in the outer arms, a bending that would not occur in isolation. They know each other, these galaxies. They are responding to one another's presence. In the deep quiet of this image, slow transformations unfold. The galaxies are patient because they have no other choice. They move at the speeds that physics permits, pulled by forces they cannot resist, toward outcomes they cannot foresee. And we watch from a distance so great that their entire histories, from first encounter to final merger, could fit within the span of a single human thought. A glance at the image, a moment of attention, and you have witnessed what took 1 billion years to occur. This is the privilege of distance. It compresses time. It turns violence into grace. Let your breathing slow now. Let the collisions continue without you, as they have continued without you for all the eons before this moment. The galaxies will find their way. They will merge or scatter, form new shapes or dissolve into the dark, and none of it requires your witness. But you are here and you are watching, and for this moment that is enough. The light from these mergers rests softly against your eyes. It has traveled so far to show you this: a universe in motion, a universe that builds and unbinds itself across spans of time we cannot truly imagine. Now we turn our gaze toward the edges of perception, where light itself grows thin, where the galaxies become suggestions rather than declarations. Here, in the deepest reaches of the Hubble Deep Field, are objects so faint that the telescope needed days of exposure to find them. Days of patient watching, days of gathering photons one by one, like collecting raindrops in cupped hands during the lightest mist. These are not the grand spirals we visited earlier. They are not the golden ellipticals resting in their ancient stability. These are small, irregular smudges of light, and they are among the oldest things any human eye has ever perceived. Let your focus soften as you look upon them. There is no need to see them sharply. They exist at the very threshold of visibility, and perhaps that is part of their meaning. The faintest specks in this image have traveled for more than 13 billion years to reach us. When their light began its journey, the universe itself was young, perhaps 700 million years old, perhaps 800 million. We cannot always be certain. The measurements are delicate, the distances so vast that small uncertainties become gulfs of time spanning hundreds of millions of years. And yet even our uncertainty carries a kind of wonder. Whether this light left its source 700 million years after the beginning or 800 million years, we are still witnessing something from near the dawn of cosmic history. Imagine, if you will, the patience of this light. Imagine a photon leaving a young galaxy, a galaxy still forming its first generation of stars, and beginning a journey through expanding space. That photon travels through the growing dark, past regions where other galaxies will someday form, through voids that will remain empty for all of time, across distances that stretch even as the photon crosses them. And after 13 billion years, after the universe has grown old and filled with structure, that single photon arrives here, falls upon a mirror in orbit around a small blue planet, and is recorded. And now, in some sense, it falls upon you. The galaxies that sent this ancient light were not like the galaxies we know today. They were smaller, often irregular in shape, clumpy and turbulent. Star formation within them was not the measured process we see in nearby spirals. It was vigorous, sometimes violent, with massive blue stars igniting in clusters and burning through their fuel in just a few million years. These early galaxies glowed with a harder light, bluer and more intense, though by the time that light reaches us, it has been stretched and reddened by the expansion of space itself. This is why the oldest objects in the Hubble Deep Field appear so red to our instruments. Not because they were red when their light departed, but because the universe has grown so much since then. The light has been stretched, its wavelength lengthened, shifted from blue toward red, and even into the infrared. When you see a faint red smudge at the edge of this image, you may be looking at something that once blazed with the fierce blue of newborn stars. Here is a small, elongated patch of reddish light. It is easy to overlook, easier still to dismiss as noise or artifact. But this is a galaxy, or what will become a galaxy, caught in the earliest stages of its assembly. Perhaps 100 million stars reside within it, perhaps fewer. By comparison, our own galaxy contains several 100 billion. This is not a failure of growth. This is simply where the story begins. All the great galaxies we see nearby, including our own, were once small and faint and distant. They built themselves slowly, through mergers and the patient accumulation of gas, over billions of years. What you see here is the foundation, not the finished structure. And beside it, another faint smudge, and another. These early galaxies often appear in groups, proto-clusters perhaps, regions where matter was slightly denser in the early universe, and where gravity began its slow gathering. Some of these objects will eventually merge. Some will fall into larger structures and lose their individual identities. Some may be destroyed entirely in the chaos of early cosmic evolution. We do not know which fate awaits any particular smudge of light. We see only this one moment, this snapshot from near the beginning, and the rest remains hidden. There is something peaceful in not knowing. The universe does not demand that we understand it completely. It offers only what light can carry across the ages, and we receive what we can. Let your breathing settle now. Notice how the faintest galaxies seem to hover at the edge of visibility, how they appear and disappear as your attention shifts. This is not an illusion or a weakness of your eyes. It is simply the nature of light at these distances. There is so little of it. The signal is faint, and our perception follows. Consider for a moment what it means to look this far. When the light from these galaxies began its journey, there were no planets like Earth anywhere in the universe. The heavy elements needed to form rocky worlds, elements like oxygen and silicon and iron, had only just begun to be forged in the cores of the first stars. Carbon, the element upon which all known life depends, was rare and precious. scattered in thin wisps through a universe still dominated by hydrogen and helium. The cosmos was not yet capable of producing a world like ours, and yet the light left anyway. It began its journey toward a future it could not anticipate, carrying information about a time when complexity was just beginning. Now that light arrives here, at a world rich in iron and oxygen, orbiting a star made partly from the ashes of earlier suns, inhabited by beings made of carbon and water who have built instruments capable of seeing to the edge of time. The light does not know this. Light knows nothing, but the connection is real nonetheless. These ancient photons complete a journey that began before the raw materials for your existence had been assembled. There is a kind of intimacy in this. The distance is unimaginable, the time scales beyond intuition, and yet the light touches your world. It ends its journey here. Some of the faintest specks in the Hubble Deep Field may not be galaxies at all, but individual objects within galaxies, bright knots of star formation, or the cores of larger structures whose outer regions are too faint to see. The distinction blurs at these distances. We classify what we can, measure what the light allows us to measure, and accept that some questions will remain open. This is not a failure of science. It is honesty about the limits of knowledge, and there is a kind of peace in that honesty as well. If you follow your gaze to the very dimmest regions of the image, where the background seems almost uniform, you will find that even here there are galaxies. They are not obvious. They require patience to see, and even then they flicker at the boundary of perception. But they are present, thousands of them, each one a collection of stars and gas and dust and dark matter, each one a world unto itself, each one separated from us by such a gulf of space and time that the word distance seems inadequate. And yet here they are, gathered in a single image, resting softly against your awareness. The Hubble Deep Field is sometimes described as a core sample through time. Near the center, where the galaxies are brighter, we see objects perhaps a few billion light-years away, still ancient but less so. At the edges of visibility, where the light has traveled longest, we approach the beginning of the era when galaxies could form at all. In between lies a continuous record, a gradient from the relatively recent to the truly primordial. When you let your eyes wander across this image, you are moving through cosmic history without leaving your place of rest. There is no need to rush through this history. It will still be here when you return. The oldest light carries with it a kind of silence, not the silence of absence, but the silence of completion. These photons have finished their long crossing. They have delivered their message from the ancient universe. Whatever happens next, the journey is done, and in that completion there is rest. Let yourself rest with them. Let the faint red smudges hover at the edge of your awareness without demanding anything from you. They ask only to be seen, and you have seen them. They ask only to be received, and you have received them. Soon we will turn our attention elsewhere, to other aspects of this remarkable image. But for now, in this moment, we remain here with the oldest light. We remain here in the quiet company of galaxies that began their existence before the universe knew how to make worlds like ours. The light is patient. It has waited 13 billion years. It can wait a little longer while you rest. Let us pause here, among these scattered islands of light, and consider something quietly astonishing. The photons arriving at the Hubble telescope during those 10 days in December 1995 had been traveling for inconceivable stretches of time. And while they crossed the void, while they moved silently through the expanding dark, things were happening here. Life was unfolding on a small, rocky world that had not even formed when some of this light began its journey. Consider the faintest red smudges near the edge of visibility. Their light left them perhaps 12 billion years ago, perhaps a little more. At that moment, our sun did not exist. The solar system did not exist. The atoms that would one day become the Earth were scattered across multiple generations of stars that had not yet been born, lived, and died. When this light started traveling toward a destination it could not have known, there was no here to receive it. There was only a region of the Milky Way filled with cold gas and ancient dust, waiting for gravity to begin its patient work. $8 billion years would pass before our sun ignited. Think about that span of time. 8 billion years of travel through expanding space while the photons drifted onward. During those 8 billion years, stars formed and collapsed. Heavy elements were forged in supernovae and scattered into nebulae. Slowly, very slowly, a particular cloud of gas began to condense in an unremarkable arm of an unremarkable spiral galaxy. The light continued traveling. It did not know that something was beginning. Let your attention drift now to a galaxy whose light is perhaps 10 billion years old. When those photons departed, the sun had just been born. A disk of debris swirled around the young star, hot and chaotic, filled with collisions. The Earth was beginning to take shape from countless impacts, a molten sphere with no oceans, no atmosphere as we would recognize it, no continents. The moon had perhaps just formed from a catastrophic collision, hanging close and enormous in a sky no one would ever see. The light traveled on, crossing voids between galaxy clusters, while below it, impossibly far below it, a planet slowly cooled. For hundreds of millions of years, the light continued its journey while Earth remained hostile to anything we might call life. The surface was bombarded by asteroids and comets. Oceans may have formed and been vaporized, formed again, stabilized. Somewhere in that warm water, in that strange chemistry, something began. We do not know exactly when. We do not know exactly how. But by the time the light had traveled another billion years, there were living things on Earth. Simple, single cells. Quiet metabolisms. The first faint pulse of biology on a cooling rock. Consider a galaxy whose light traveled for 9 billion years. When those photons left their home, life on Earth was microbial. For the next 3 billion years, while the light crossed intergalactic space, life remained almost entirely microscopic. Bacteria, archaea. Gradually, slowly, cyanobacteria began filling the atmosphere with oxygen, a poison to most existing life, a transformation that would take hundreds of millions of years. The light traveled on, patient and unknowing, while a planet slowly rusted, while iron in the oceans combined with oxygen and fell to the seafloor in bands of red. "3 billion years of microbial life. The light was still traveling. Now turn to a galaxy perhaps 6 billion light-years away. Its light left when Earth was already ancient, already home to life for more than 2 billion years. But still, nothing you could see with your eyes. Still, no animals, no plants, no movement except the invisible churning of single cells. The continents drifted. The atmosphere changed. Occasionally, the entire planet froze over, a snowball Earth, and then warmed again. The light continued traveling through the dark, indifferent to these rhythms of ice and thaw. By the time this light had crossed half its journey, something new had begun on Earth. Cells with nuclei appeared, eukaryotes, complex life though still invisible to the naked eye. The light traveled another billion years and multicellular organisms emerged. Soft things in shallow seas. No shells yet, no bones, no hard parts. Just tissue and movement, the first faint suggestions of bodies. Consider a galaxy 4 billion light-years away. When its light departed, the Cambrian explosion was still hundreds of millions of years in the future. There were no fish, no insects, no land plants. The continents were bare rock and dust, washed by rain, shaped by wind, utterly silent. The oceans held life, but it was soft and strange, forms we would not recognize, leaving few fossils. The light traveled on. Half a billion years later, the Cambrian arrived. Suddenly, in geological terms, hard shells and complex eyes, trilobites, anomalocaris, the ancestors of everything that would follow. The light from our 4 billion year distant galaxy was still traveling, still crossing voids, while on Earth the first vertebrates appeared, jawless fish moving through ancient seas. Let us rest with a galaxy whose light has traveled 3 billion years. When those photons departed, life on Earth had just begun to colonize the land. Small plants, perhaps fungi. the first hesitant green at the edges of water. Fish were developing jaws, developing bones. The light traveled on. By the time it had crossed another few 100 million light years, there were forests. Insects filled the air. Amphibians crawled from the water. Coal swamps covered the continents, and the dragonflies of that era had wingspans as wide as a human arm, though humans were still hundreds of millions of years from existing. The light traveled on through the Permian, through the greatest mass extinction Earth has ever known, when nearly all life vanished. It traveled through the Triassic, when the ancestors of dinosaurs appeared, small and tentative at first. It traveled through the Jurassic, when great sauropods walked and early birds took flight. Still traveling, still crossing the dark. Now consider a galaxy whose light traveled for 500 million years, a shorter journey than most in this field, yet still a span that dwarfs human comprehension. When this light departed, the dinosaurs had already been dead for 15 million years. Mammals were diversifying. Forests looked almost modern. Early primates moved through those trees, small and nocturnal, watching with wide eyes. While this light crossed the relatively small distance of 500 million light years, continents continued their slow drift. India collided with Asia and the Himalayas began to rise. Grasses evolved and spread and the great grasslands appeared. Horses evolved from small forest creatures. Whales returned to the sea. The light traveled on. Consider an even nearer galaxy, perhaps 200 million light years away. When its light departed, early hominids were beginning to walk upright in Africa. Australopithecus, perhaps, or its ancestors. The light traveled on while stone tools appeared, while brains grew larger, while ice ages came and went. It was still traveling when Homo erectus learned to control fire. Still traveling when Neanderthals lived in Europe. Still traveling when our own species appeared, perhaps 300,000 years ago, though the light had less than 200 million light years still to cross. For most of that remaining journey, humans lived as hunter-gatherers. The light traveled on while we painted caves, while we buried our dead with flowers, while we followed herds across continents we would not name for many thousands of years. The nearest galaxies in the Hubble Deep Field sent their light perhaps 1 or 2 billion years ago. When we look at them, we see them as they were while fish swam in ancient seas, while the land was just beginning to be colonized, while the moon hung closer and the days were shorter and nothing yet had learned to breathe air. All of this history unfolding while photons drifted through empty space. The light did not know. The light does not know. It simply traveled, following the geometry of space-time, crossing distances so vast that no metaphor can truly hold them. And here is what settles over you when you consider this. The light arriving from the most distant galaxies began its journey before the sun existed. It has been traveling for longer than our world has been a world. The light from the nearest galaxies in this field began its journey when life was still learning to crawl onto land. Everything humans have ever done, every city built, every word spoken, every moment of love and grief and wonder has occurred in the final fraction of the journey of even the closest light in this image. We are late arrivals to a story already in progress. The light does not need us to witness it, but we are here and we can. Let that thought rest with you. The silent patience of photons crossing billions of years. The slow unfolding of a planet from molten rock to living world. The strange circumstance that allows you to be here, now, aware of both. These are not dramatic facts. They are quiet ones. They ask nothing of you except perhaps a moment of stillness, a recognition of scale, a willingness to let the numbers become something felt rather than merely calculated. The galaxies continue to drift across your vision. Their light continues to arrive, as it has for billions of years, as it will for billions more. What happens next on Earth in the next billion years is not something we can know, but the light will keep traveling. The universe will keep unfolding, and somewhere, perhaps, other eyes will look up and wonder at the slow patience of it all. The image you have been drifting through is small, smaller than you might have imagined when you first entered it. The Hubble Deep Field covers a portion of the sky so slender that you could blot it out with a grain of sand held at arm's length. A single grain of sand. That is all it would take to hide these thousands of galaxies from view. Consider that for a moment. Let it settle into you like something heavy finding its place on a shelf. The telescope pointed at almost nothing, a dark and empty patch where few stars from our own galaxy intruded, and it found all of this. Spirals turning through gold and white, ellipticals glowing with the soft amber of ancient populations, irregular wisps caught mid-collision, faint red smudges from the earliest epochs of galaxy formation. All of this hidden behind a grain of sand. And now the question arrives quietly, the way questions do when you have been still for long enough. If this small patch contains so much, how much more must the full sky contain? The mathematics are simple, almost gentle in their precision. The celestial sphere, the imaginary dome of sky that surrounds us in all directions, can be divided into approximately 13 million patches the size of the Hubble Deep Field. 13 million identical squares of darkness, each one capable of holding its own treasury of distant light. If each patch contains roughly 3,000 galaxies, as this one does, then the full sky must contain something close to 40 billion galaxies, perhaps more, perhaps somewhat fewer. The number shifts as astronomers refine their methods, as deeper surveys reveal fainter populations, as definitions of what constitutes a galaxy are reconsidered. But the order of magnitude remains. Tens of billions of galaxies surround us in every direction. $40 billion is not a number the mind can hold. Not truly. You can write it, speak it, perform calculations with it, but you cannot picture 40 billion of anything. The human imagination, shaped by evolution to track a few dozen individuals in a social group, to count the animals at a watering hole, to estimate the days until winter, has no framework for such quantities. And so you let the number rest as an abstraction, a symbol pointing towards something real but unreachable. This is not a failure of imagination. It is simply a recognition of scale. Some truths can only be approached, never grasped. And there is a kind of peace in that, in knowing that the universe exceeds us, that it was never meant to fit inside a single mind. The galaxies you have been watching drift past are real, each one a gravitationally bound system of stars, gas, dust, and dark matter. Each one with its own history, its own populations of worlds, its own long tale of formation and evolution. And they are only a sample, a single sip from an ocean so vast that the word ocean fails to capture it. Imagine, if you can, extending this journey in every direction. Not just forward through this slender column of space, but upward, downward to every side. Imagine the Hubble Deep Field multiplied 13 million times, each copy tilted to cover a different portion of the sky. The galaxies would not overlap. They would not crowd each other out. Space is large enough and the galaxies are sparse enough that each one would have its own coordinates, its own unique position in the cosmic web. This is what astronomers mean when they speak of the observable universe. Not the full universe, which may extend forever, but the portion we can see. The sphere of space from which light has had time to reach us since the beginning. Within that sphere, tens of billions of galaxies drift in their slow dispersal. Each one a system of hundreds of billions of stars. Each star potentially hosting worlds. The numbers cascade outward, each level multiplying the last, until the counting becomes a kind of meditation rather than an exercise in arithmetic. And yet the sky appears dark. This is the ancient puzzle that carries the name of Heinrich Albers, though others pondered it before him. If space is filled with galaxies, and each galaxy shines with the light of countless stars, why is the night sky not blazing with brilliance? Why can we stand beneath the heavens and see darkness between the stars? The answer has several layers, each one quietly profound. The universe is expanding, and the most distant galaxies are receding so quickly that their light stretches into wavelengths our eyes cannot perceive. The universe is not infinitely old. and light from the most remote regions has not yet arrived. The galaxies are scattered thinly across such tremendous volumes that their combined glow, averaged over the full sky, amounts to a faint background hum rather than a blinding flood. Darkness is not emptiness. Darkness is distance and time, and the gentle reddening of ancient light. When you look at a patch of night sky that seems to hold nothing, you are looking through all of those receding galaxies, all of that stretched and faded light, all of that history traveling toward you at the only speed it can. The darkness is not absence. It is presence that has not yet made itself known. This is why the Hubble Deep Field matters. It transforms what appears empty into what is abundantly full. It reminds us that our senses evolved for other purposes, for finding food, for recognizing faces, for navigating landscapes on a single small world. The universe was never designed to be obvious to us. It reveals itself slowly, through instruments and patience, through long exposures and careful analysis. And still, even with our best instruments, we are sampling. The Hubble Deep Field is one column. Later surveys, the Hubble Ultra Deep Field, the Hubble E Extreme Deep Field, looked deeper and longer, finding even more distant galaxies, pushing closer to the beginning of time. The James Webb Space Telescope, with its infrared eyes, sees farther still, catching light that has been stretched beyond what Hubble could detect. Each generation of instruments adds another layer to our senses. But no survey covers everything. No telescope has the time or the resources to stare at every grain of sand across the entire sky with the same depth and patience as these deep fields. And so we extrapolate. We take our samples and multiply. We assume that the universe is roughly the same in every direction, that the patch of sky above the North Star contains as many galaxies as the patch above the Southern Cross, that what we see here is representative of what we would see anywhere. This assumption, called the cosmological principle, is well supported but never fully proven. It is a working hypothesis, a scaffolding that allows us to build larger estimates. Perhaps there are regions of the cosmos that differ from our samples, vast walls of galaxies, enormous voids with almost nothing inside, structures so large that they dwarf anything in the Hubble Deep Field. There are hints of such things in wider surveys that sacrifice depth for breadth. The universe appears to be textured, with filaments and clusters and empty spaces arranged in a pattern that some have likened to a sponge, or a web, or the foam on a breaking wave. But even the voids are not truly empty. Even the darkest corners contain faint galaxies, dim and isolated, drifting alone through regions where neighbors are few. There is no place in the observable universe where galaxies are entirely absent. They are everywhere in varying densities, like a dust that permeates all of space. And what of the universe beyond the observable? The portion from which light has not yet arrived, the portion that may extend forever in all directions. We cannot see it. We may never see it. Some cosmologists suspect that the full universe is far larger than the observable sphere, perhaps infinitely larger. If so, the number of galaxies is not merely 40 billion. It is without limit, a number that cannot be written because it has no end. This is speculation, not observation. It is a possibility that follows from certain models and assumptions, but it is worth holding in mind gently as you drift through this small sample of what exists. The Hubble Deep Field shows you 3,000 galaxies. The full sky may contain 40 billion. The full universe, if it extends forever, may contain more galaxies than any finite number can express. And you are here in this moment, watching light from a few of them, watching shapes that formed billions of years ago, watching spirals that may have changed beyond recognition by now, watching ellipticals that have grown through mergers, or faded through stellar death, or continued much as they were, watching faint red smudges whose galaxies have long since transformed into something more familiar. This is the nature of the view. It is partial. It is delayed. It is a message that takes billions of years to arrive and covers only a fraction of what is out there. And still it is enough to evoke wonder. Still it is enough to let you sense, in some quiet way, the scope of what surrounds us. The galaxies continue to drift. The light continues to arrive. The numbers, vast and patient, rest at the edge of thought. You have been drifting for some time now. The galaxies have passed like lanterns in a dark corridor, each one a sphere of light suspended in the quiet. And perhaps you have begun to sense something about this image, something that was always present but became clearer with each passing moment. This is not simply a photograph. It is something else entirely. When we speak of the Hubble Deep Field, we often describe it as a window into the distant universe, a window into the past. But this word, window, suggests something passive. It suggests you are merely looking through glass at a scene that exists somewhere else. The truth is more subtle and more profound in its subtlety. What you have been watching is not a snapshot frozen in time. It is time itself, layered and compressed into a single frame. Each galaxy occupies not only a different region of space, but a different moment in the history of everything. When you look from one edge of the image to the other, you are not simply scanning across distance. You are scanning across billions of years. Consider what this means. The light from the nearest galaxies in this field left its source perhaps 2 or 3 billion years ago. The light from the farthest left more than 12 billion years ago. Between those 2 points, the universe changed in ways almost impossible to comprehend. Stars formed and died. Galaxies merged and separated. The cosmos itself expanded, stretching the fabric of space, cooling the primordial heat into something that could eventually hold planets, hold oceans, hold the quiet chemistry of life. All of this is present in the image, not described, not illustrated, but actually present. The photons themselves are the evidence. They carry the timestamp of their origin in their very existence. This is why we call it a time machine, though the phrase may sound fanciful. It is not fanciful. It is simply accurate. The Hubble Deep Field allows you to see the past directly, without interpretation, without reconstruction. The light you observe is ancient light. It has traveled across the expanding universe for eons, untouched by anything along the way, until it arrived at a mirror orbiting a small blue planet and was focused into data, into color, into this image. You are not looking at a representation of the past. You are looking at the past itself, preserved in light. Imagine for a moment that you could hold this image in your hands. Imagine it as a physical object, a pane of glass perhaps, or a translucent sheet. If you could somehow reach into it, your fingers would pass through layers of time. The foreground galaxies would be closer to your touch, separated from you by only a few billion years. The background galaxies would be deeper, further, separated by most of the age of the universe. You could not touch them in the same moment because they do not exist in the same moment. They never did. This is the nature of looking outward into space. Every direction is also a direction into the past. There is no way to see the universe as it is now, in this instant, because light takes time to travel. Even the closest star, a mere 4 light years away, is seen as it was 4 years ago. The sun itself is 8 minutes old by the time its light reaches your eyes. And the galaxies in this image, the faint red smudges and pale spirals, they are millions upon millions of years old in our view. We are always looking backward. This is not a limitation. It is simply how the universe works, how light works, how time and distance intertwine. And so the Hubble Deep Field becomes something more than a survey of distant objects. It becomes a kind of archive, a library of moments, each one preserved in the medium of light, each one waiting to be observed. When astronomers study this image, they are not merely cataloging galaxies. They are reading history. They are tracing the evolution of the cosmos from its earliest visible structures to the more familiar shapes of the present era. In the deepest parts of the image, where the galaxies are smallest and reddest, we see a universe that was still young. The first generation of stars was burning, hot and blue and short-lived. Galaxies were still assembling, still finding their forms. The heavy elements that would eventually build planets and people, carbon and oxygen and iron, were only beginning to be forged in stellar cores. It was a different place, the early universe, hotter, denser, more chaotic, and yet already beautiful in its way, already following the same physical laws that govern everything today. As your eye moves forward in time, moving toward galaxies whose light is slightly younger, you see the universe settling. Spiral arms begin to emerge. Elliptical shapes become more defined. The blue glare of young stars gives way to a softer palette, gold and amber and white. Dust lanes appear, dark threads winding through the bright. The cosmos is maturing, finding the patterns it will hold for billions of years to come. And in the nearest galaxies, the ones whose light is merely a few billion years old, you see something almost familiar. These are galaxies not so different from our own. Large spirals with elegant curves, small irregulars with bursts of new stars, clusters and groups bound by gravity, moving together through the dark. These are the galaxies that exist in what we might call the recent past, though even this recent past predates any life on Earth. All of this is visible in a single image. All of this is present at once, not because the universe is frozen, but because light carries memory. Each photon that arrives at the telescope is a messenger from a specific place and a specific time. Together, they create a mosaic of eras, a composite of ages, a view that spans most of cosmic history. This is what it means to look at the Hubble Deep Field. You are not seeing one moment. You are seeing many moments, layered upon each other, arriving simultaneously at your eye. And there is something peaceful in this, something calming. The past is not lost. It is out there, still traveling, still arriving. Every beam of light that reaches us is a thread connecting the present to the past. We are surrounded by ancient light at all times, though we rarely pause to consider it. The Hubble Deep Field simply makes this visible. It shows us what is always true, that the universe is a place where distance and time are woven together, where looking far is the same as looking long ago. The light from these galaxies has been traveling since before the Earth existed, before the sun ignited, before the solar system coalesced from its cloud of gas and dust. It has been traveling through an expanding universe, redshifting slowly, stretching into longer and longer wavelengths. And now, after all that time, it has arrived. It has arrived at a telescope built by a curious species. A species that wondered about the dark spaces between the stars and decided to look more closely. A species that built instruments to gather faint light and asked questions about what that light might mean. This is remarkable, though the word is perhaps too strong. Let us say instead that it is quiet, and it is true. The universe does not hide its history. It sends it outward in all directions at the speed of light, and anyone, anywhere with the patience to look can receive it. The Hubble Deep Field is one such act of looking. One small telescope, one small patch of sky, one long exposure. And in return, the universe offered billions of years of its past, compressed into a single image. You have been drifting through that image. You have seen galaxies young and old, near and far. You have watched light that left its source when the cosmos was a fraction of its current age. You have been a witness to time itself, spread out before you like a map. And now, as the drift slows, as the image begins to settle into stillness, there is nothing more to do, no conclusion to reach, no final revelation. The galaxies remain. The light continues. The universe goes on as it always has, as it always will. You are here in this moment, having looked backward across eons. The image is a time machine, and you have used it, not to change anything, not to travel in any physical sense, but simply to see, to witness, to let the ancient light fall gently into your awareness. This is enough. This has always been enough. The quiet act of observation, the patient gathering of photons, the willingness to sit in the dark and wait for the universe to speak. The Hubble Deep Field does not ask anything of you. It simply shows you what is there, what has always been there, waiting in the dark, waiting to be seen. And now you have seen it. The galaxies drift in silence. The light rests, and you, in your own small corner of space and time, are free to close your eyes.